All right, let's take a look at simplifying, multiplying, and dividing rational expressions. A little bit of your math brain. Can you do all this stuff without a calculator? Because the foundation of today's lesson is based on your prior knowledge of fractions. So let's just see how your math brain is checking out. So when you look at something like this with a fraction of 12/16, which 12/16 is something that you should be, pretty familiar with in just reducing that fraction. Well, we can include letters in there and we still do the same thing. So you begin by looking at that and going, well, I can handle that because this divides by 4 3 times, this divides by 4 4 times, and I get the 3/4. All right, if you want to take your time to split up, what is 8x squared? Well, it's actually 2 times 4 times x, and then 12x is 3 times 4 times x, so you're going to get some factors that cancel or reduce, and so then you'll notice that these 4's and these x's have gone away, and we're down to 2x over 3, because essentially 4 divided by 4 makes a 1, x divided by x makes a 1, and so those reduce themselves out of the fraction, and your final answer is the 2x over 3. All right, then you also should have learned multiplying fractions is no problem. You multiply the tops and you multiply the bottoms. Kind of an old rhyme maybe from your middle school days. And then you look at this and you can use that idea as you're multiplying fractions with letters or without letters. So let's take a look at how this plays out. You're going to get the answer of 1/3 here because you could multiply first and get 8/24. 2 times 4 is 8, 8 times 3 is 24. Okay, then after that, your next step is obviously reduce it, and you reduce it and you get 1/3, the answer that we already had. But what if you choose to reduce first? So I would suggest that maybe reducing first is a smarter idea, because then you end up cross-canceling and cross-reducing. 4 divides by 4 once, 8 divides by 4 twice, so you're taking a multiple of 4 out of each of those. Getting smaller numbers to work with is always nice. And then you end up getting 2/6 once you multiply those together, and then remember that 2/6, both of those are even. You can reduce that then back over here to the 1/3 that we already had. So you can either multiply first if you like, or reduce first when working with just plain fractions. All right, it also applies to fractions that are multiplied with letters in them. So I can go ahead and cross reduce. 3 divides by 3 once, 12 divides by 3, so I divide these both by 3, I divide these both by 2, get the corresponding numbers, and then I'm going to cancel out the x terms because I have an x squared here and an x to the 4th here, so 2 of these cancel 2 of these, knocking them down. Okay, now I'm all left with, I had a 1 times a 1 times a 4, which is 4, a 1 times a 4 times an x squared, which is 4x squared. This looks like a good answer, but you better notice that those are both even. They're actually both the same number, so then those reduce to make a 1. 4/4 is 1 whole, and you end up with 1 over x squared. All right, division. Do you remember this little rhyme? Dividing fractions, my oh my. Flip the fraction on the right and multiply. So you're basically just going to flip this one and do that multiplicative inverse, or multiplicative reciprocal is a word I'm sure you've used. And then you turn that into multiplication, and you notice that these two flipped over, and I turned it into multiply. So then I will then do my cross reducing, because 8 and 12 both divide by 4, 7 and 7 both divide by 7. Shrink those numbers down, and you have a 1 times 3, which is 3, and a 2 times 1, which is 2. Much easier to work with. Now let's use that same thinking to work with rational algebraic expressions, oftentimes just called rational expressions. So now you're going to have something that looks like I want to try to cancel. Ooh, look at this. I want to cancel. No, this is a division line. It doesn't reduce subtraction or addition. So things that are separated by subtraction or addition are not undone by division, so you cannot get rid of those. But you could if it was written as multiply. So if I rewrite this as its factored form, which is x minus 3 times x plus 1, there's a multiply between there. And guess what? Division undoes multiply, so now I'm free to do some reducing. So the two that reduce are the x minus 3 divided by x minus 3 terms, and you're left with the x plus 1 over x minus 4. So this whole big original fraction is actually the same thing as x plus 1 over x minus 4. Next, we're going to multiply. Well, the multiplying of fractions is no problem. You multiply the tops and you multiply the bottoms. So what I did is I broke it down into factored parts, because now I have them separated by multiplication, which division then can cancel it. And so then what you'll notice is after all of the factoring, this one you should notice is difference of squares. Got that. This one is just take out the common factor. I did that. And these were regular factoring ones over here. So then the first two canceled, made a 1, those divided out. The 5, x minus 5 here and the x minus 5 over here, because they're separated by times, I can just cross cancel those. And there also is an x plus 2 set right there, giving me the same thing as x over x minus 2. There was a lot of reducing that I was able to accomplish in that one. All right, now what about division? Don't freak out by that because you just multiply by the reciprocal. So flip this one over, turn that into multiply, and you're in great shape. So we turned it into multiply, we flipped it over, and we factored the difference of squares, noticing that, factoring out a common factor here, and now looking for things that are going to reduce. So the x plus 3's divide out, and then the x and the x squared, 1 power of this cancels 1 power of this, leaving 4 on the top. That's the only thing that's left here. Then I've got this random 3. Oh, it looks like I forgot an x because there was 1 power here and 2 powers here. There should be an x right there, and then x minus 3. So there should be an x right there where my arrow's pointing. Sorry for the typo.